So, Elon, having achieved this this milestone here, what does that mean for the future of SpaceX and for the future of spaceflight?
Yeah, I think this is a really good milestone for the future of spaceflight. I think it's another step towards the stars. In order for us to really open up access to space, we've got to achieve full and rapid reusability. And being able to do that for the primary rocket booster is I think, going to be a huge impact on cost. Now, it'll still take us a few years to make that smooth and make it efficient, but I think it's proven that it can work. And there probably will be some failures in the future, but we will iron those out and get it to the point where it's a routine. It's routine to bring it back, and where the only changes to the rocket are, maybe to hose it down or clean, give it a wash and add the propellant and fly again. That's the key. Full and rapid reusability is fundamental. Yeah.
Bill?
Oh. Well, Marcia was ahead of me. I'll let Marcia go in front of me.
Okay, Marcia, go ahead.
Marcia Dunn, Associated Press for Mr. Musk. Where do you expect the stage that landed in December on land, where's that going to end up? Is that going to be on display at your headquarters ultimately?
Yeah, soon, hopefully.
Hopefully? Is that the plan?
We just got, our headquarters are close to or adjacent to the Hawthorne Airport, so we needed FAA permission because it would be like the highest object for quite a distance around the airport, but we just, I believe, got that permission. So we're planning on putting the rocket that landed back at the Cape in front of the SpaceX headquarters in Hawthorne, hopefully in the next few months.
Oh, okay. Thank you. And could you tell what was the velocity and the altitude for this booster? What's the highest altitude it reached in its peak speed before it started coming back?
So actually, I don't actually know.
200 usually.
Yeah, for LEO missions, the peak altitude is usually not super high. Like it's would have been something around a couple hundred kilometers, and the velocity also is not as high as it would have been on the last mission. The highest velocity missions that we see are the geostationary missions. So for example, for this mission, actually we could have brought it back to land, but we wanted to do a ship landing where we had lots of margin. So it would have been a low margin return to land or a high margin ship landing, and so this, I think, really helped us show that the ship landing could work. But in terms of the maximum sort of transfer velocity, which is this is really the key figure of merit for the boost stage. The maximum transfer velocity is we think we'll get up to about 9,000, maybe 10,000 kilometers per hour, and that's transferring an upper stage load, upstage with payload plus fairing. You're talking about 120 tons or thereabouts. So it's 120 tons to upwards of 10,000 kilometers an hour. So it's sort of quite a javelin throw.
Bill?
Yeah, Bill Harwood, CBS News. Two very quick questions. One is, I realize it was a fairly calm sea today, but those of us not used to looking at barges in the ocean, looked like it was rocking pretty good. What is, just out of curiosity, the maximum tilt the rocket could stand and stay vertical, number one? And two, can you talk a little bit about increasing your launch pace? You guys have a really busy manifest. You're starting to ramp things up here, and do you need more people? Can you do it with the crew you currently have here and at Vandenberg? Just generally about the pace. Thanks.
Sure. Well, first of all, I'd say it's a ship. It used to be a barge, but when we added engines and control systems and everything, so now I think it's sort of fair to call it a ship. Has 4 engines, but today the pitch and roll was about 2 to 3 degrees, so it was actually not too bad. In terms of maximum, well, probably, I'd say we could do double double that easily and maybe triple. So maybe it's 8 or 9 degrees, but that's probably about the limit. But that would be really intense seas. You also see some translation where it's going up and down, so it's both rotating and translating. So it's tricky, just like a carrier landing. But it's, I mean, and both are going to absolute position. So the ship is holding to absolute GPS position with a relative GPS, and today was actually holding to with accuracy of below a meter. And it's got 4 engines that all of which can rotate in 360 degrees, and they're operating continuously to hold both the attitude and position in the ocean. In terms of increasing our head count, I think that's going to continue to grow, and our launch rate is going to continue to grow. We're expecting by maybe the third or fourth quarter that would be doing a launch every 2 to 3 weeks.
Stephen?
Thanks. Stephen Clark from Spaceflight Now. A couple of clarifications. I believe earlier you've talked about securing the rocket on the drone ship with welded shoes. I was wondering if that's still
that's what's happening.
That's still
we're
the
welding
plan?
it down. Yeah,
and
make sure it doesn't tip over. There's potentially some heavy winds coming in. So once the rocket's safe, the crew's going to go on there, and then we've got these steel shoes that we put over the landing feet and weld it to the deck.
And one more clarification: is it still coming into Port Canaveral? Is that the plan?
Actually, I'm not certain about that. I think that certainly is where it will ultimately be. I'm not sure if that is the initial destination.
Okay.
All right, let's come back over here onto this side of the room. Right here. Right here.
All right. Sawyer Rosenstein with Talking Space. Kind of going along with that, can you talk a little bit about the process of exactly how it gets, to that drone ship, how it stays on that drone ship, and then the process of what exactly happens from now that it's on until it gets back into port?
Sure. We're a little bit like the dog that caught the bus, It's not what we do now. The plan is to bring it into port, then take there's a load head fixture that we can put on the top of the rocket, kind of where the stage separation mechanism attaches, and then we can pick it up with the crane and then put it onto land. And then we've got we actually have like a stand that we put it on, and then the stand attaches the launch hold downs, and then we can fold the legs up. Then the crane rotates it horizontal for transport, and should bring it back to probably 39A, and then we're going to do those 10 test firings, and if that all goes well, then we think we'll be comfortable with an orbital flight.
Okay, right here.
Jason Ryan with SpaceflightInsider.com, and I kind of want to take back a little bit to Orbcom OG2 this past December. You successfully landed at Landing Zone 1, kind of carrying out a test flight there, and today you carried out a test flight more or less on ocean. So can you talk a little bit about SpaceX's plans to actually incorporate the testing of its technology successfully, I might add, while still sending payloads to orbit? Thank you.
I'm not sure I totally understand the question. So, you mean, I'm not sure I understand the question. Incorporating SpaceX's technology to
Test flights while you're still sending payloads to orbit. I mean, most
yeah.
people, they break up their test program away from sending payloads to orbit, but you've actually managed to incorporate the two. Can you talk a little bit about that philosophy?
Yeah, sure. Well, I guess the problem with as soon as you're going to orbit, your horizontal velocity. I really can't emphasize horizontal velocity enough. It's because it's so counterintuitive. It's super high. So it's really hard to do these test flights without actually going to orbit. We could conceivably, I suppose, put a huge weight, 120-ton weight on top of the boost stage, and then do these launches, drop the 120-ton weight, and then try to land. But there's no point doing that. Why not just send a useful payload while you're at it instead of the dead weight? So, but that's why it's really hard to do these tests. Like, it's really basically impossible to do these tests on land, unless you had like Siberia or something, because it's just if something were to happen and the rocket engines didn't relight, it would have a ballistic trajectory and land like hundreds of miles away, like several, like, anywhere from 500 to 1,000 miles away. So it could randomly smash down on a city somewhere. That's why you want to do the ocean launches. So if it isn't able to turn around and relight the engines, then it's going to sort of smash into the ocean harmlessly.